Well, we're talking about linear relations and functions, and specifically, we're being asked to be able to identify a linear function by looking just by looking at an equation and identifying whether that is a linear function or not. And remember now, a linear function or a linear relation that is a linear function is going to be characterized by that when you graph it, it is going to be a straight line. If you graph a linear function and it's not a straight line, then it's called nonlinear. We'll be looking at those as well, but right now, our focus of our attention is going to be on linear functions. So let's take a look here, and we're going to go and look at some examples of how we can recognize by looking at an equation whether this is a linear function or not. Now, before we actually look at some examples, let's kind of go over some rules that'll help us as we're looking to identify whether a function is a linear function or whether it's going to be a nonlinear function. And there's certain rules that apply that will help us develop this skill. So first, I guess, would be to look at what is not a linear function. And there's certain things that we can see that we can look at in an equation and help us instantly to determine that what we're looking at is not a linear function. So one is if we see two variables being multiplied together in the equation, it is not a linear function. Another rule that we can apply is if we see a variable in the denominator of a rational number or a fraction, and the variable is in the denominator, it is not going to be a linear function. Also, if the variables have any kind of exponent other than 1, and remember now, if the exponent is just 1, it's almost never ever going to, you're not ever going to see it expressed as x to the first power. But if we see any exponent other than 1, we can determine instantly that's not going to be a linear function. Another rule that we would apply is if we see a variable under a radical or a square root or cube root or some type of root, then also again, it is not going to be a linear function. So what is a linear function? How can how can we see it and recognize it as an equation that it's a linear function? Well, if any equation could be written in slope-intercept form, which is in the form of y equals mx plus b, then it's going to be a linear function or a linear equation. And we may have to rearrange it, rewrite it, the equation, to make it fit this slope-intercept form. But if that can be done, then we can know that that's going to be a linear equation or a linear function. Or if it's written in standard form being ax plus by equals c, where a, b, and c are all real numbers. If an equation is written in that form, then we can know that it is a linear function or equation. So we got certain rules that will tell us what disqualifies it as a linear function: two variables multiplied together, a variable in the denominator, any variable has an exponent other than 1, or when a variable appears under a radical, not going to be a linear function. Okay, well, let's take a look at some examples. Let's say I've got an equation that is 6y minus x equals 7. And we're being asked to identify if this is a linear equation. And I can say yes to this, because so even though this is not written exactly in slope-intercept form, y equals mx plus b, where m is actually slope, b is a constant, or in standard form, ax plus by equals c, I could rearrange this equation and make that fit either slope-intercept or standard form, and so this would be a linear equation. Now, how about let's take a look at this one. Let's say we got 9x equals 18 over y. So would this be a linear equation? Well, the answer to that is no. And the reason for that is that we've got a variable in the denominator. And that variable in the denominator is going to tell us that that is not an example of a linear equation. That's going to be some type of nonlinear equation. Let's say we've got, let's look at a third one here. Let's say we've got f of x. Let me change colors. Go back to black here. F of x equals, that f of x tells us that this is a function notation, 4 minus x cubed. All right. Well, this is not going to be a linear function because we have an exponent here. Got an exponent right here that is greater than 1. And so just by looking at that, that can tell us that's not going to be a linear function. And let's see if we can't find one more right quick. Oh, here's one. Let's see. We've got, let's say we've got an equation that is 2yx equals 3y plus 2x Okay, so we got 2xy equals 3y plus 2x. The fact that we've got these two variables being multiplied together right here is going to tell us that that equation is not a linear function. So there's just a few examples. One where it is a linear equation, and looking at 3 here that give us an example of what is not a linear function. So hope that helps. Let's march on.